Alright, this is going to be our last video on rational functions. Today, or in this video, we're going to specifically talk about slant asymptotes. Now these are going to be, again, imaginary lines. That's all an asymptote is. But it's going to be an asymptote that is not horizontal, it's not vertical. We have to find the equation for that line. So there's a way to do that. So to find the slant asymptote, we're going to use long division, and the quotient is the equation of the asymptote. If through this process of long division we have a remainder, we're going to ignore that when we're finding our slant asymptote. So before we even look at an example of graphing and finding a slant asymptote, let's just look at if we have a function, say we have f of x equals x squared minus x over x plus 1. We want to find the slant asymptote of that. We're going to take x squared minus x plus 0, and we're going to divide that by x plus 1. So remember from class we did long division with polynomials. So we have to ask ourselves, how many times does x go into x squared? Well, that's x times. And then we multiply x by x plus 1. X times x is x squared. X times 1 is plus x, and we're going to subtract that entire expression from x squared minus x. Well, x squared minus x squared, it's gone. But a negative x minus x makes a minus 2x, and then we bring down our plus 0. So now we ask ourselves, how many times does x go into negative 2x? That is negative 2 times. So we go negative 2 times x, negative 2x, negative 2 times 1, minus 2. We subtract that entire expression. The 2x terms cancel each other out. 0 minus negative 2 is 2. So we have a remainder of 2 over x plus 1. But our slant asymptote, which I'll abbreviate as SA, is going to be the equation y equals x minus 2. Which means for this function, x squared minus x over x plus 1, if we drew a dotted line through x minus 2, the line equals x minus 2. That line is something that the graph of f of x will never cross. So now let's actually look at an example where we're going to graph a function and find its slant asymptote. So first, this is example 3. We're going to have the function f of x equals x squared minus x minus 2 over x minus 1. We're going to, let's start by finding that slant asymptote, and then we'll simplify it to find anything else we need. So we're going to take x squared minus x minus 2, and we're going to divide that by x minus 1. Well, we ask how many times does x go into x squared? That's x times, so we have x squared minus x, and we're subtracting that entire thing, which means x squared minus x squared gone, negative x minus negative x also gone, so we're going to have 0, but we still have to bring down the minus 2. So then the question is, well, how many times does x go into 2? Well, it doesn't. So we write plus 0, which means we actually have our remainder, because if we subtract everything, we're going to get our long division answer is x minus 2 over x minus 2, which means our slant asymptote is going to be the equation y equals x. So when we do graph it, we'll take care of that. Now, let's go and find our y-intercept. And I think I'm going to just use this entire page to gather all of our important things, and then we'll do a graph on a new page. So our y-intercept, we're going to put 0 in for x and solve it. So we're going to have 0 squared minus 0 minus 2 over 0 minus 1, which is going to just give us negative 2 over negative 1, which just equals 2. So our y-intercept is at the point 0, 2. Let's also find our x-intercept. Right now we're just gathering all of our important information. So we need to know for what values of x would make the numerator 0. So we can solve x squared minus x minus 2 equals 0 for x. I'm going to solve it by factoring because I think this one is a fairly simple factor, because we need to think what numbers multiply to make negative 2 that add to make negative 1. I can only think of negative 2 and a positive 1. So if we set each of these equal to 0 separately, we'd have x minus 2 equals 0 and x plus 1 equals 0. We would have x equals 2 and x equals negative 1. So our x-intercepts, we've got 2 of them this time, are going to be at the point 2, 0 and negative 1, 0. Now when we're looking for vertical asymptotes, we ask ourselves if we set the denominator equal to 0, x minus 1 equal to 0, for what values of x would that be true? So let's solve it for x. We'd add 1, and we'd find x is equal to 1. So we'd have an imaginary line there. And I'm going to go and circle all the important stuff we've found so far, because we're actually almost done finding that. If we find our horizontal asymptote, remember we look at our leading terms in our numerator and denominator. And if our numerator has a higher degree than our denominator, then there is no horizontal asymptote, so we have none, because we have an x squared in our numerator and only a single x in our denominator. So let's turn over to a graph. We still have to find a few other important points, but let's start graphing the stuff we have. So we're going to make our xy axis and then we're going to put in the points and asymptotes that we know. So we know we had a slant asymptote when y was equal to x. Now that line goes through the origin, and if we have a rise over run of 1, our slant asymptote, and mine's a little bit off, but it's going to look roughly like this. Then we found out that our vertical asymptote is at x equals 1, so we can make a vertical line through x equals 1, but we're going to do dashes with these asymptotes because that says that it's not actually included in our graph. We also found that our y-intercept was at the point 0, 2, so we're going to put a point there, and that we had x-intercepts at the points 2, 0, so we'll put a dot there, and negative 1, 0. So we'll put another dot there. Now we want to pick a point that's to the left and right of our intercepts and asymptotes. And I'm thinking, when I look at this, I'm not going to worry about a point that's between the x-intercept that's on my left at x equal at negative 1, 0. And I'm not going to worry about a point between that and my y-intercept. I'm just going to pick a point on either side. A point that's to the left of my x and to the right of my y-intercepts. So a point that's to the left of my x-intercept, we could go and find f of, I don't know, negative 2. So let's take our original equation, which was negative 2, or x squared, so negative 2 squared minus negative 2 minus 2 over negative 2 minus 1. Well, negative 2 squared, that's 4. When we minus a negative 2, that's like adding 2. Minus 2 over negative 2 minus 1 is negative 3. And I notice in my numerator, the 2 and the minus 2 cancel each other out. So we're just going to get 4 over negative 3. So at negative 2, we're going to get negative 4/3, which is about negative 1 1/3. So we're just going to go down 1 and a little extra and put a dot. And then how about we pick something that's to the right of 0? And we can't do 1, so let's do half. We'll do f of 0.5. So we're going to have 0.5 squared minus 0.5 minus 2 over 0.5 minus 1. And you know what? I would just use a calculator to find this. If you plug all of that into a calculator, you're going to find that you're going to get a value of 2.5. So at 1/2, we're going to go up to and about halfway to 3. We've got points now that we can connect. What we know is we can never cross y equals, or not y, well, y equals x. We can't cross that, and we can't cross x equals 1. So we've got that part done. We're good there. Now let's graph the other side. We need to ask ourselves, let's pick up x and to the left and to the right of 2. And we can't do 1. So what if we do 1.5? And what if we do 3? So let's do the 1.5 first. So we're looking for f of 1.5. Well, we're going to go 1.5 squared minus 1.5 minus 2 over 1.5 minus 1. And again, go ahead, use a calculator. What you're going to find is you're going to get negative 2.5. So at 1.5, so between our vertical asymptote and our x-intercept, we're going to go down 2 and halfway to the next one. Now let's find f of 3. So we're going to have 3 squared minus 3 minus 2 over 3 minus 1, which you can use a calculator, but we don't need it for this one. We're going to get 9 minus 3 minus 2 over 2, and 9 minus 3 minus 2 is 4. And 4 over 2 is equal to 2. So at 3, we know y equals 2, and we've got points now that we can connect with a smooth curve. And now we finished graphing x squared minus x minus 2 all divided by x minus 1. We put in our important information. We found our asymptotes. There were no wholes, no common factors between our numerator and denominator, so we were good there. We're done.